Now we want to learn some special functions, typical functions we often have in our real life. The first function is called a quadratic function. So the quadratic function is given by this form: f of x equals ax squared plus bx plus c. Okay. So here a is not 0. So in other words, the square term always exists. Otherwise, it's called a linear function, right? If you just have bx plus c, this is called a linear function. But if we have some square term, ax squared, then we call it quadratic function. So this is called the standard form of quadratic function. So if you have a quadratic function, so what is the graph of the quadratic function? And we know that for the square function is a very special quadratic function. F of x equals x squared, right? We know the graph of the square function looks like a parabola, right? The lowest point, which is the origin. This is the square function. Square function is a special form for the quadratic function where a equals 1 and b equals 0 and c equals 0, right? So here I would tell you that the graph of the quadratic function always have the graph of the quadratic function f of x equals ax squared plus bx plus c. Here a is not equal to 0. The graph of the quadratic function always have the parabola shape. If a is greater than 0, then the parabola will open up. If a is less than 0, the parabola will open down. So this is the typical shape for the quadratic function. It's a parabola shape. Okay. So the domain of the quadratic function, the domain is all the x values we can plug in. So the domain is all real numbers, right? Domain is all real numbers. All real numbers. Okay, so now let's look at the intercept. So the y-intercept is very easy. Y-intercept, which is we set x equals 0. So f of 0 would be a times 0 squared plus b times 0 plus c. So it's equal to c. So the y-intercept would be 0, c. Okay, so this is the y-intercept. What about the x-intercept? So from the intercept, we can know how the parabola will intersect the x-axis and the y-axis, right? So how to do the x-intercept? X-intercept, do you remember that? We set y equals 0, right? So here means ax squared, y equals what? Y equals f of x. So f of x equals 0. So ax plus bx, ax squared plus bx plus c equals 0. So this is called a quadratic equation. Right? We want to find the root of this quadratic equation. So how to find the root of the quadratic equation? One way is to factorization. The other way is called quadratic formula. we use the quadratic formula to find the root x values. So how to find the root? So x equals, so here just give you the recall, x equals negative b plus or minus square root b squared minus 4ac over 2a. Right. So this is the quadratic formula. So in other words, so here we require that b squared minus 4ac should be greater than or equal to 0. Otherwise, they have no real root. So in other words, if xb squared minus 4ac less than 0, then x has no real roots. In other words, i.e., there is no x-intercept. Okay, there is no x-intercept. So the graph would be looks like this one. If opens up, no x-intercept would looks like this one. If opens down, it could be this one, right? There's no x-intercepts. But we always have the y-intercept. Y-intercept equals is 0c, right? If fb squared minus 4ac equals 0, that means x equals, then we use the quadratic formula, so this term would be 0, right? So you have x equals negative b over 2a. So in other words, we only have one x-intercept. So x-intercept is negative b over 2a, comma 0. So from the graph, it will look like this one. So the parabola touches x-axis at one point, right? If greater than 0, then we have two x-intercepts. Two x-intercepts. One is negative b plus square root b squared minus 4ac over 2a, comma 0. The other one is negative b minus square root b squared minus 4ac over 2a, comma 0. Okay. So the typical graph will look like. So the typical graph will look like this one. We have two intercepts. One is here, one is here. Or like this one is here and one is here. Opens up, opens down, depending on this. A is positive or negative, right? So you can use the quadratic formula to determine the x-intercept. So now I want to look at which is called the vertex form. Vertex form. So why we are interested in the vertex form, the reason is the vertex form gives you more information than the standard form. So this is the standard form, which is ax squared minus plus bx plus c. What is the vertex form? The vertex form is given by this form, a x minus h square plus k. We have a complete square then plus a constant. This complete square multiplied by a, then plus a constant k. So here, if you expand, then you compare these two, you will see that here h is equal to negative b over 2a, where k is equal to c minus b squared over 4a. So this is the formula you need to know. We can use this formula to find the vertex form directly from the standard form. Right? If you have the standard form, you can use this formula to find the vertex form quickly. So why we are interested in the vertex form? The reason is the vertex form can tell you many informations. For example, if you have we will not draw any y-axis, okay, for our convenience. You can put a y-axis as you want. So you have a parabola. Okay, so this is the case for a greater than 0, right? This is the case for a greater than 0. You have a parabola. The vertex form tells you that the lowest point is what? H of k, h comma k, which is negative b over 2a, comma b c minus b squared over 4a. Okay, b squared over 4a. If a greater than 0 opens up, and this one tells you that it is the lowest point on the graph. So this one will give you a minimum value, a minimum value of f of x is the f values of this point, in other words, the y coordinate of this point, which is c minus square over 4a. Okay, which is actually, you can get this number by plugging the x coordinate of this point into the function, which is f of negative b over 2a. So then you don't need to memorize this complicated formula. You just need to know the h of this point, the x coordinate of this point, which is h, which is b negative b minus 2a, b negative b over 2a. Then you plug in this one into the function f of x, then you will have the k value, which is c minus b squared over 4a. Okay, so this is this one. It also tells you there is a symmetric form, symmetric line, which is x equals symmetry line equals h. Okay, x equals h is the symmetry line. So in other words, if you fold this graph about this x equals h, the graph will coincide each other. Okay. So this is the symmetry line, symmetric line, symmetric line, or line of symmetry. And x and y intercept is very easy. You just set x equals 0, then you get y, and y equals 0, you get x, right? So this is this case. If a is less than 0, then the graph will open down. Then this is the vertex. Right? So here, this one is called a vertex. This is called a vertex, this point. And here is this point is called a vertex. This point, the vertex is still h comma k. The same formula. But you can see if a is less than 0, the vertex would be the highest point on the graph. So this point will give you a maximum value of this function f of x, which is f of negative b over 2a. Okay? You plug in this one into the function f, then you will get this is y equals f of x. Then you plug in here, then you get the y coordinate of this point, which is equal to c minus b squared minus 4 over 4a. Okay, so this is the difference. The symmetric line is still x equals h, right? So the only difference is here it gives you the minimum value, which is c minus b squared minus over 4a. Here gives you the maximum value, which is c minus b squared over 4a too. But it depends the sine over a. If a is greater than 0, you will have a minimum value. You have no maximum value because the curve will increase forever. If a is less than 0, then you will have the maximum value, but you have no minimum value because the curve will go down forever. Okay, so now let's look at some examples.